trinomials. There are two different types of trinomials. One is with a lead coefficient of 1, and the second is when your lead coefficient, or your a value, the coefficient of your x squared term, is not equal to 1. So before we take a look at factoring, what I want you to remember is when the trinomial is in factored form, we have two binomials. So we end up with, if we were going to multiply this out and distribute, we'd start with x times x, which is x squared. So when you have a trinomial with your x squared term, you'll start to factor it into two binomials using the x times x. To get the middle term, you end up with x times 3, which is 3x, and negative 9 times x, which is negative 9x. Those two terms, I'm not quite done multiplying out, but those two terms combine to negative 6x. We add them together to get our middle term. And then our last term comes from negative 9 times 3, which is negative 27. So when you start with a trinomial where the lead coefficient of 1, again, your x squared term is alone, there's no coefficient other than 1. To find the two numbers that go into the binomial when you factor, you will look for numbers that add to negative 6. That's where we got our positive 3 minus 9. We combine those by adding, and multiply to negative 27. The method that I use for this is called the T-chart method. All right, so we're starting with our first trinomial. We've got x squared minus 7x plus 12. So we identify our b and c. Our b is negative 7, and our c is 12. So I've got my T-chart set up. We need it to multiply to c, or 12. And we need it to sum or add to b, which in this case is negative 7. So in the first couple, I went through all of the different possibilities just to show you, but I think for the most part, if you guys know your multiplication charts, you should be able to figure out these numbers fairly easily. So one option would be 3 times 4 is 12, and 3 plus 4 is 7. Well, that works for one of them. It multiplies to positive 12, but it doesn't add to negative 7. We could have negative 3 times negative 4, which does add to negative 7. So as soon as we find those, we don't need to bother checking the rest of the options. We substitute this solution that works in both cases into our binomial, x minus 3, x minus 4. What's really nice about factoring is that you always have an automatic check. You should never get the wrong answer when you're factoring. So how do we check? We distribute. X times x is x squared. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. And negative 3 times 4 is positive 12. And again, combining our like terms, we end up with x squared minus 7x plus 12, which is the trinomial we started with. So we have that factored correctly. Second case here, our b term, remember, is the coefficient of, in this case, y, which is 3. Our c term is the constant, which is negative 10. So using our T-chart, we need to multiply to negative 10 and add to 3. So our first option is 5 times negative 2, but 5 plus negative 2 is 3, so we found ours right away this time. So we have y plus 5, y minus 2. Again, we have all of the other possibilities of multiplying to 10 listed. The common ones that people forget about are the ones where it's the number times 1. It didn't work out in this case, but when you are setting up your T-chart, if you're having a hard time finding two numbers that will add to that middle term, make sure you're checking number times itself. And we could go ahead and distribute to check, but that one does work. All right, so another example. This time we've got our b term is 17, and our c term is 16. So setting up our T-chart, we want to multiply to 16 and add to 17. So when I see the number 16, the first thing that I think about is 4 times 4. But 4 plus 4 is 8, not 17. So then I think 8 times 2, but 8 plus 2 is 10. So this is one of those where we do have to think about the fact that 1 times 16 multiplies to 16, and 1 plus 16 is 17. So in this case, our factored form is n plus 1, n plus 16. All right, so the next factoring method is the AC method. So this is where the coefficient of your x squared term is not equal to 1. What we have to do here is convert it to a quadnomial with 4 terms and use the factoring by grouping method. It's called the A times C method because our first step is to multiply our A times C. So we have that written out here. Our A is 2 and our C is negative 15. So 2 times negative 15 gives us negative 30. Then what we do is we set up that t-chart we just looked at, multiplying to A times C, multiplying to negative 30, and adding to our B term, which in this case was 1. So we have negative 6 times 5, which multiplies to negative 30, and negative 6 plus 5 is negative 1. So if we flip those signs around, 6 times negative 5 is negative 30, and 6 plus negative 5 is positive 1. So these are the 2 terms we want. What we do with those 2 terms is we replace that x with 6x and negative 5x, because 6x minus 5x equals 1x. So essentially what this is doing is this is putting it in that distributive property, that first line that we get before we've added our like terms. And then we factor by grouping. So we've got that set up for us down here. Common factor for 2x squared and 6x is 2x. We have an x left over and a 3 left over from the second term. In our first binomial, we notice that the x and 3 are both positive. So when I'm looking at this negative 5x minus 15, I know that I want to factor out a negative number, so that's what's left in the parentheses as positive. Our common factor here is 5. So we've got x plus 3 left, which is what we want. That's the same as the binomial from our first grouping. So we factor out that x plus 3. And what's left from our first term is 2x. And what's left from our second term is negative 5. So the factored form of that trinomial we started with is x plus 3 times the quantity 2x minus 5. So again, I want to multiply this out using the distributive property to show you how all of this works together. So we start with our x times 2x. So this is just checking our answer. We get that 2x squared. X times negative 5 is negative 5x. 3 times 2x is positive 6x. So if you look at these 2 terms, that's what we came up with from our t-chart, that same 6 and minus 5x, and we replaced those before we did our factoring by grouping. And finally, we have that 3 times negative 5 is negative 15. So when we combine those middle terms, we get that 2x squared plus x minus 15 trinomial that we started with. All right, we'll just go through a couple more of those. So in this case, our A term, our first coefficient, is 4, and our C term is negative 15. So 4 times negative 15 gives us negative 60. So we set up our t-chart. We want to multiply to negative 60 and add to negative 4, our B term. So when I see negative 60, a couple of things that I think about: 4 times 15. And knowing that I need to add to a negative, I know that the larger of my 2 numbers needs to be negative. But 4 plus negative 15 is negative 11, so that one doesn't work. I know 5 times 12 equals 60, but 5 plus negative 12 is negative 7. So then I'm thinking 6 and negative 10. 6 times negative 10 is negative 60, and 6 plus negative 10 is negative 4. So those are the terms that I want to use when I'm rewriting my trinomial. So I'm going to set this up as 4y squared. And that middle term, instead of being a negative 4y, will become a positive 6y minus 10y. Again, we get those from the t-chart. And then our c stays a minus 15. So I'm going to factor by grouping. So I'm going to group my terms together. My first 2 terms, I have a common factor of 2y. Dividing 4 by 2, I get 2. Pulling a y out, I have a y left. 6 divided by 2 is 3, and I pulled the y out. And my second 2 terms are both negative, so I want to pull out a negative so that those 2 numbers in the binomial are positive. 5 is my common factor, my greatest common factor. So I'm left with 2y plus 3, which matches what I have in my first binomial. So then I can factor this as 2y plus 3 times the quantity 2y minus 5. And again, we could double check our work to make sure that we have that factored correctly. One more example. This time our a is 3, our c is 1. So we need to multiply to 3 and add to 4. Well, the only numbers that multiply to 3 are 1 and 3. And since we're adding to a positive, we know we want both of those to be positive as well. So 1 plus 3 gives us 4. So rewriting our trinomial, I'm going to have 3x squared. And instead of the plus 4x, I'm rewriting that as a plus 1x plus 3x from those two terms we just got in our t-chart. And my c stays the same at plus 1. Factor by grouping in my first two terms here, I have a common factor of x, which gives me 3x plus 1. Remember, x divided by x is 1, so don't lose that placeholder. My second two terms, my greatest common factor is 1. And when you're factoring by grouping, you do want to put that 1 there so that when you pull out your greatest common factor, you can see that there's a 1 left. So we've got 3x plus 1 is our common factor on both terms, and x plus 1 is what's left. All right, so that is factoring trinomials. Tomorrow we're going to take a look at putting all of the types of factoring together and doing some combination factoring.